Hi guys, this is my second video on engineering models, and today I will be talking about the ball bearings. So let's take a look how the ball bearings look. This is a clear picture of a ball bearing. You can see there are balls and the covering. The ball bearings are actually available in many sizes and shapes. So today we will talking about the history of the ball bearing, the assembly via CAD design that is designed by me, the material selection, the applications, and the working of the ball bearings. So I must say that total credit for the designing manufacturing of the first ball bearing completely goes to Mr. Philip Voken, who designed this first ball bearing design in 1794. At that point of time, this ball bearing design was much appreciated by the people because it actually reduces many failures at that time of the shafts. After some time, a mechanic also came up with the same idea of the ball bearing. Oh, just forget that. Now, these ball bearings find their application in many parts of the world, be it of extreme temperature, pressure, or humidity. Based on that, the engineer made their wise selection for selecting the best material for designing the ball bearing. Hence, today three type of material are greatly used to manufacture the ball bearing. These are the stainless steel, the chrome steel, and the ceramics based on their application. Stainless steel are actually used when the temperature, or I must say the environment, is quite humid. So the stainless steel is good against corrosion. Hence, these are used in the humid climate or in the ocean or the seas. Secondly, chrome steel are used when the shaft itself is very heavy or carries heavy load. The ceramics are used when the ball bearings are operated at high temperatures, as ceramics can withstand very high temperatures. So today I will be talking about the assembly and the working of the ball bearings by looking at our CAD model. You can see here how the ball bearings actually looks like. This is how a ball bearing looks like in reality. This is known as the outer race. This is known as the inner race. The outer race is generally fixed in a ball bearing and inner race is movable part. So when the shaft gets rotated due to some kind of external force that you have provided to the shaft, that can be via motor that runs on battery or chemical energy, that gets rotated. And when the shaft gets rotated, it exerts a torque over the inner race, and the inner race move along with the balls, and this part is generally fixed. Now again, we will be talking about why to use this ball bearing. These ball bearings are used to reduce the bending and to reduce the friction. So again, going towards our CAD model, we will see why to use them. So take a look from this side. You will see that this part of the shaft is fixed towards the motor and this part is free. So there can be a bend in this shaft. It can be bending like this. As the cursor move, it can be bending like this. So if we want to reduce that bending at any part, we use the ball bearing at that point, as it can withstand high forces, high radial forces. The other reason is to reduce the friction. Just imagine a situation in which these ball bearings are not used and only two pieces of metal are used. There will be a lot of friction and lot of heat will be coming out, and that will be resulting a lot of wastage of energy. Hence we use the ball bearing design. We have talked about why to use a ball bearing. Now I will be talking about the forces that acts on ball bearing when the shaft actually moves, and in the other case if it rests over the ball bearing. There are two types of forces. One is the axial force and another is the radial force. Now The axial force is the force in the axial direction, that is the direction of the shaft, and the radial direction is the direction towards the ball, like towards the direction of the ball, moving radially outwards. So there are two types of forces we have discussed. Now I will be like talking about the reason for the failure of the ball bearings. There are many reasons, but I will be like telling some of the good reasons. One is the very much friction. High friction can lead to failure of the ball bearing. High friction losses can lead to great heat generation, and that heat generation can lead to the failure of the ball bearing. Second is the environmental condition, like if we are in a like deserted condition and suddenly rain falls, that is a weird situation, but imagine that condition. So environmental condition change, and hence it can lead to the failure of the ball bearings. Other is the wrong material selection. This is also a great reason for the failure of the ball bearings. Let's take an example. If you're using the ceramics ball bearing for high temperature boilers, okay, high temperature boilers, and like suddenly we are using those boilers in cold conditions, there's not hot conditions, and suddenly we are using great heavy shafts for that, so the ceramics cannot withstand such high loads, thus this will be a wrong material selection. Other is the balls moving very less or not moving at all. This is also a reason. Let's again take a look. Let's imagine the balls are not moving or are moving very, very slowly. The shaft is moving at its own rotational speed. So when the shaft rotates, it provides a centrifugal force towards the ball, and as well as there will be a force on the downside ball due to the weight of the shaft. So if the balls are moving very slowly or are not moving at all, so for a larger time period, the downward ball will be experiencing a lot of force that can lead to the plastic deformation of the ball bearings. Hence, if the balls are moving very slowly, it can lead to plastic deformation. Thus, to reduce the plastic deformation, these balls should be always moving at a constant or by speed. I've talked about the reason of the ball failures of the ball bearing. Now I will be like talking about the applications. The ball bearing find the application in various machines, mechanical machines, in the fans, skateboards or the skates, and as well as in the car gears. Now I've covered all the topics for today. Now you can take a look over my CAD model for better understanding. This is how it works. You can take a look from all the sides. Thanks for watching, guys. I hope you liked my video. Please subscribe my channel, like my video, and in the next part I will be like talking about a great engineering application or engineering model, that is the water pump. Thanks guys for watching my video. I hope you like it. Bye bye.